Problem number 1. Using the Pascal's triangle to expand a binomial expression. Let us use the Pascal's triangle to expand this binomial expression. 2x plus 3y raised to the power 3. Recall, in the last lesson we constructed this binomial triangle, and I won't go over it. If you don't know how it was constructed, please refer to the previous lesson. Okay, so which columns which rows rather are we going to use as coefficients for expanding this binomial expansion? Simple. If the power is 3, then the column to use is the column which has the second term as 3. So in this particular case, the coefficients for this expansion, for the terms of these expansions, will be 1, 3, 3, and 1. I repeat, if the power is 3, then we simply look at the second term, second number, which is 3, and hence use these as what? As our coefficients. Next, so we've got the coefficient 1 here, which corresponds to that 1 there. We've got the coefficient 3 there, which corresponds to that 3 there. We've got the coefficient 3 there, which corresponds to that 3 there. And we've got the coefficient 1 there, which corresponds to that 1 there. Next, we're going to raise 2x raised to power 3, which is that one, and 3y, which is the second term, raised to power 0. And then once we've done that, all that we're going to do next is the first term, the power on the first term will be reducing by 1. So if we reduce that 3 by 1, we get that 2. We reduce by 1 again, we get 1. We reduce by 1, we get what? 0. And the coefficient and the power on 3y, which is the second term, will be increasing by 1. So from 0 to 1 to 2 to 3. It's as simple as that. Next, we're simply going to apply laws of indices to simplify the whole lot of that. Okay, so let's apply the laws of indices. Before we even apply the laws of indices, what we're seeing here is that anything raised to power 0 is 1. So we're supposed to have a 1 there, which we haven't written, because in mathematics we usually we don't write 1. We've also dropped that 1, but it's supposed to be there. So here we'll only remain with what? 2x raised to power 3. Here we've got this 3, which is on there, and then 3y raised to power 1. According to the laws of indices, anything raised to power 1 is simply itself. That's why I haven't written the 1 there. Then on the third term, we've got that 3 corresponding to that 1 there. Again, 2x is raised to power 1, and anything raised to power 1 is itself. That's why I haven't written the 1 there. And then we've got this 3y raised to power 2, which is that 1 there. Okay, so again, 1, haven't written the 1 there. 2x to the power 0 is 1. That's why I haven't written the 1 there. And then we remain with what? 3x to the power 3y to the power 3. That's the only thing which is going to remain there, because of this 1 times that, which won't change. Alright, next we continue applying the laws of indices. We know that according to laws of indices, numbers which are in brackets or raised to a power if we're multiplying anything in brackets raised to everything raised to a common power, it means that everything within that bracket is raised to that power. So this 2 will be raised to power 3, which is 2 to the power 3, and x as well will be raised to power 3. So we're going to have x to the power 3 like that. In the same way, that 2 raised to power 2 and x raised to power 2. That's why we have that. Okay, and if we come here, 3 will be raised to power 2, which is that one, and y will be raised also to the power 2, which is that one, and 3 will be raised to power 3, and y will be raised to power 3 as well. Okay, and then simplifying that, we know that 2 raised to power 3 is simply 2 times 2 times 2 gives us 8. Here 2 raised to power 2 is 4. Here 3 raised to power 2 is 9, and 3 raised to power 3 is what? 27. Okay, so simplifying that further and removing the brackets, in brackets x 8 multiplied by x raised to power 3 can simply be written like that in mathematics. Here we'll multiply that 3 times 4, which gives us 12, and then times 3, that will give us what? 36. So 3 by 4 by 3 is 36. Then we've got that x squared there and the y. So we've got 36 x squared y. Here we will multiply that 3 multiplied by 2 multiplied by 9, which will give us 54. And we've got that x corresponding to that x there, and we've got y squared corresponding to that y squared. And obviously here we simply got what? 27 y cubed, which will give us that. Okay. Next, what I want you to do is to use the Pascal's triangle to expand the following binomial expressions. Okay, so we're simply going to use this Pascal's triangle here, okay, and use it to expand these following that order. Okay, after you've done that, you can view these references. You can find more examples from these references from John Baird, Engineering Mathematics 6th edition, and from commonly known as Pure and Applied 6th edition as well. Thank you.